Welcome, dear students. I am teacher Sharon De Silva and I'll be teaching you geometry in this video. We are going to learn about chapter number 3, circle, in this particular video. So let us begin. I'm sure you all know about what a circle is. You have been studying about circle and its properties in lower classes as well. A circle is a shape consisting of all points in a plane that are a given distance from a given point, the center. You are familiar with the concepts regarding circle like center, radius, diameter, chord, interior and exterior of a circle. Also recall the meanings of congruent circles, which are shown over here. Congruent circles, exactly same. Concentric circles, one inside the other. And intersecting circles, circles which meet each other. Circles passing through 1, 2, 3 points. In the adjoining figure, point A lies in a plane. All three circles with centers P, Q and R pass through A. Over here. How many such circles may pass through point A? If your answer is many or innumerable, it is correct. Infinite number of circles can pass through a point. Now we are doing, it's an activity which we are going to discuss. Draw segment AB. You can refer to figure number 3.6. Draw segment AB and draw perpendicular bisector L of segment AB. Take point P on line L as center, PA as radius and draw a circle. Observe that the circle passes through point B also. Find the reason. Now over here you need to recall the property of perpendicular bisector of a segment. If you remember, perpendicular bisectors divide a segment into two equal halves. So if PA is the radius, PB will also be a radius. So here if PA is the radius of the circle, PB will also be a radius because both the distances are equal. So circle will also pass through B. Taking any other point Q on the line L, if a circle is drawn with center Q and radius QA, will it pass through B? Yes. The same concept will be applicable over here as well. If QA is the radius, QB will also be the radius and the circle will also pass through B. How many circles can be drawn passing through A and B? And where will their centers lie? So you can have a figure something like this. So innumerable circles or many circles can be drawn passing through both these points and their centers will lie on the perpendicular bisector. Next activity. Take any three non-collinear points. Non-collinear points, points which are not in a straight line. What should be done to draw a circle passing through all these points? Think about it. Can you draw a circle passing through all 3 points? Yes, if they are at equal distance from the center. Now draw a circle passing through these points. Is it possible to draw one more circle passing through these 3 points? Think about it. We can have a figure something like this over here. These are 3 non-collinear points A, B, C, and we have drawn a circle passing through all 3 points. Can we have one more circle passing through all 3 points? Yes, you're right. It is not possible. Next activity. Take 3 collinear points. Collinear points, points which can pass through or points which are in a straight line. Now try to draw a circle passing through these points. Is it possible? If you are not able to draw a circle, think of a reason. So we can have a figure something like this. Over here, the points are P, Q and R. So this is one possibility. This is another possibility. These are collinear points. So we cannot have a circle passing through all 3 points. It is not possible. We can have 2 points at a time, 1 point at a time, but not all 3 points. So my dear students, on the basis of these activities, what have we learned? Infinite circles pass through one point. You can see the picture over here. Through one point, many circles are passing. Infinite circles pass through 2 distinct points. There is a unique circle passing through 3 non-collinear points. Unique means one and only one. And no circle can pass through 3 collinear points. The next concept what we are going to discuss, my dear students, is of a secant and a tangent. Now what are these? If you look at figure 3.8, the first circle what we have, it's like a circle with center A and a line L. If you see, both are at a distance, they do not have anything common in between them. If you see the second circle, circle with center B and line M, both touch each other at a particular point, and that point is common to both the circle as well as the line. So such a line which touches a circle at one particular point is called as a tangent, and that point over here, point P, is called as point of contact. And the third figure, my dear students, a circle and a line, they touch each other in 2 different points, point Q and point R. Both these points are common to the circle with center C as well as line N. So such a line which touches the circle in 2 distinct points is called as a secant of a circle. So I'll repeat, a tangent is a line which touches the circle in one particular point, and a secant is a line which intersects or touches the circle into 2 distinct points. Now we are going to discuss about or study about tangent theorem. So what is a tangent theorem? A tangent at any point of a circle is perpendicular to the radius at the point of contact. I'll repeat, a tangent at any point of a circle is perpendicular to the radius at the point of contact. Now, my dear students, this is an indirect proof. I'm sure you know how indirect proofs are written. So let us start. Now over here we have a figure 3.10. Line L is a tangent given information to the circle with center O and the point of contact is point A. We have to prove that this particular line L is perpendicular to radius OA. Now let us start. We are going to assume that, give me a minute. We are going to assume that line L is not perpendicular to OA. Suppose I have segment OB drawn perpendicular to line L. So I'm assuming this is like a construction. OB is perpendicular to line L. So it looks something like this. I have OB perpendicular to line L. This is my construction. And B is not same as A. That means A and B are not same points. They are different points. Now I have to take another point C on line L such that A dash B dash C and BA is equal to BC. So my figure will look something like this. A dash B dash C and I have BC is equal to BA. So let us begin. In triangle OBC and triangle OBA, I have BC is equal to BA. This is on the basis of construction. And angle OBC is equal to angle OBA because this over here B is perpendicular to L. So we have 90 degree, both are 90 degrees. And OB, segment OB is equal to segment OB, that is common segment. So I have triangle OBC congruent to triangle OBA by SAS test of congruency, and on the basis of that I can say that OC is equal to OA, the reason corresponding sides of congruent triangles. But OA is the radius given information. That means OC will also be the radius. Therefore, if OC is radius, so C lies on the circle. That means line L now intersects the circle in two distinct points, A and C. But according to given information, line L is a tangent. And tangent cannot intersect a circle in two distinct points. It has to intersect in one and only one point. That means our assumption that line L is not perpendicular to radius OA is wrong. Therefore, line L is perpendicular to radius OA. So with this, we prove the tangent theorem. And what is that? A tangent at any point of a circle is perpendicular to the radius at the point of contact. My dear students, this is all for now. We will meet in the next video. Till then, have a nice day. Thank you for watching.